In the vast, frigid expanse beyond Neptune lies a celestial body that has captivated our imagination for nearly a century. Pluto, once considered the ninth planet, has always been shrouded in mystery. Its distance from Earth, over 3 billion miles, made it a challenging target for even our most powerful telescopes. For decades, Pluto remained a blurry, pixelated dot in our cosmic view, a frozen relic of the early solar system. Early observations painted a picture of a desolate world, locked in a perpetual deep freeze. Its surface, we believed, was an unchanging landscape of ancient ice and rock, a place where time stood still. But the universe, as we are constantly reminded, holds surprises for those who dare to look closer. And Pluto, as it turns out, had a few secrets up its icy sleeve. Then came the James Webb Space Telescope, our most powerful eye on the cosmos. With its unprecedented infrared vision, the JWST pierced through the veil of distance, revealing Pluto in astonishing detail. What we saw challenged our long-held assumptions about this distant world. Pluto, far from being a static, frozen wasteland, is a geologically active and dynamic world. Towering ice mountains, some as high as the Rockies, cast long shadows across nitrogen glaciers. Vast canyons, deeper than the Grand Canyon, scar the surface, hinting at a tumultuous past. Smooth plains, likely formed by recent geological activity, stretch for hundreds of miles. These discoveries sent shockwaves through the scientific community. How could a world so small, so far from the sun, maintain such geological vigor? The answer, it seemed, lay beneath the surface. At the heart of Pluto lies a vast, heart-shaped region known as Sputnik Planitia. This enigmatic feature, covered in nitrogen ice, has captivated scientists since its discovery. The JWST's observations have only deepened the intrigue. The smooth, relatively crater-free surface of Sputnik Planitia suggests that it is geologically young, perhaps less than 10 million years old. This points to a process of constant renewal, reshaping the surface and erasing the scars of past impacts. But the most tantalizing discovery lies beneath this frozen surface. Scientists believe that a vast subsurface ocean of liquid water may exist beneath Sputnik Planitia's icy shell. This ocean, potentially larger than all of Earth's oceans combined, could be kept liquid by the heat generated from radioactive decay in Pluto's core. The implications of this discovery are profound. If true, Pluto joins the ranks of Europa and Enceladus as a potential harbor for life beyond Earth. The source of Pluto's surprising geological activity remains a subject of intense scientific debate. One leading theory points to the gravitational dance between Pluto and its largest moon, Charon. Unlike most planet-moon systems, where the moon orbits the planet in a relatively circular path, Pluto and Charon are locked in a gravitational embrace. They orbit a common center of gravity that lies outside of Pluto itself. This unique configuration creates powerful tidal forces that stretch and squeeze both bodies, generating internal friction and heat. This tidal heating, combined with the decay of radioactive elements within Pluto's core, could provide the energy needed to power the geological processes observed on its surface. The constant push and pull of gravity may be responsible for the towering mountains, deep canyons, and the potential subsurface ocean beneath Sputnik Planitia. The Charon connection, it seems, is key to understanding Pluto's hidden depths. Charon, once thought to be a simple, cratered world, has also surprised scientists with its complexity. The JWST has revealed a surface sculpted by geological activity, including deep canyons, towering cliffs, and vast plains. The presence of reddish-brown material, likely tholins, suggests a complex chemical history. Recent observations have also detected the presence of carbon dioxide and hydrogen peroxide on Charon's surface. The presence of these compounds further fuels speculation about Charon's geological activity and its potential to harbor the building blocks of life. The discovery of these compounds on Charon adds another layer of intrigue to this enigmatic moon. Their presence suggests that Charon is not simply a passive bystander in its dance with Pluto, but an active participant in the complex interplay of forces shaping this distant world. Pluto, despite its small size and distance from the Sun, possesses a thin but dynamic atmosphere. Composed primarily of nitrogen with traces of methane and carbon monoxide, this atmosphere expands and contracts with Pluto's elliptical orbit. As Pluto moves closer to the Sun, the ices on its surface sublimate, replenishing the atmosphere. When it retreats to the outer reaches of its orbit, the atmosphere partially freezes and falls back to the surface as snow. The JWST has observed haze layers in Pluto's atmosphere, extending hundreds of miles above the surface. These hazes are thought to be composed of complex organic molecules, including tholins. The presence of tholins, created by the interaction of sunlight with methane and other atmospheric gases, hints at the possibility of prebiotic chemistry taking place in Pluto's atmosphere. The discoveries made by the JWST have rekindled the debate about the possibility of life beyond Earth. Pluto, once considered too cold and distant to support life as we know it, now presents itself as a potential candidate in the search for extraterrestrial life. The potential for a subsurface ocean, the presence of organic molecules, and the evidence of ongoing geological activity all point to a world that may be surprisingly hospitable to life. While the search for life on Pluto is still in its infancy, the discoveries made by the JWST have provided us with a roadmap for future exploration. Dedicated missions to Pluto, equipped with orbiters, landers, and even robotic submarines, are being considered. These missions could confirm the existence of a subsurface ocean, analyze its composition, and search for signs of life in this alien environment. The implications of finding life on Pluto would be profound. It would shatter our current understanding of the limits of life in the universe and force us to rethink our place in the cosmos. Pluto, once relegated to the status of a dwarf planet, may hold the key to answering one of humanity's oldest and most fundamental questions. Are we alone?